Alright, time for another DrivePhysics.com, debatephysics.com also, but nobody available to counter-argue anything I will argue. Just the fact they won't provide any coherent counter-argument. Nobody. Can't find anybody, can't pay anybody to argue what's actually being stated and argued. So the first thing we'll take care of is the proof. Okay, they claim they have proven, okay, beyond the reasonable person's doubt, that a two mass and a one mass, given velocities, right, that all I have to do, this has a certain weight. I give it a velocity, let's just say one velocity for the hell of it, and it will do a certain amount of work. You could measure it with a spring, for example. A weight, it'll produce a pressure. And they say that all I have to do is increase this velocity to 1.4. I just have to make it go 0.4 faster. Not twice as fast, not even, 1/2 faster. This was, say this was 10. I don't have to make it go 15 even. I certainly don't have to make it go 20. All I have to do is make it go 14, velocity, and it will produce the same pressure. So I can have half the mass and create the same pressure, just increasing the velocity 0.4. That is, I could take a 16-pound bowling ball and throw it down the bowling alley, or I can choose to take an 8-pound ball and just throw it 0.4 faster. Not much, 0.4. That's all I need. And I'll have the same power to knock down pins. Now, even though, it can be understood that, when the ball hits the pins, it's just going to be momentum that's exchanged. The pins are going to leave with momentum, and the momentum is going to be extracted from the bowling ball. I mean, is there any other rational explanation for what actually happens to the pins? I don't think so. So this all goes back to the simple gravity argument. But I mean, that's what they're saying they've proven. Alright. So I mean, if I just reverse their experiment, pushing things poorly. So they push things badly, actually. That's all they do. And the fact is if I had some system to put the energy back in, that is, just put your little cars on a track, have them go back up a hill and see how much energy they come back with. And I guess it'll be kind of obvious that the momentum it comes back with won't be as much momentum as this one. Just as a fact. But they don't care about facts. So they mock the very idea that somebody would talk about, actually getting the facts right. So they also think that if I shoot something into something gravitational, or I drop it, so I just do these two different things. I start with something going 500 miles an hour, and I start with something going 0 miles an hour, that this thing, that'll take, say, 10 seconds to get to its maximum velocity, and will take 10 seconds in the gravity, where this, going 500 miles to start with, will cover this exact same distance in 1 second. And they think, their argument is that both these things collect the same amount of extra velocity. So if this ends up being 550, when it hits the ground, this will be 550. I mean, this will be 50. It'll be the extra. So no matter how fast I push it through the gravity, it collects the same energy. So this is 50, and this will be 550. Even though you can understand that, no, it's only going to be in the gravity 1 second. This is going to be in the gravity 10 seconds. It's going to collect 10 times as much extra velocity as this will collect. Now I could just say, that's a fact. Now I'm sure it's been tested. And it's just the truth. The longer you're in the gravity, the more it's going to affect you. So I've made these simple arguments that you could just do the test the simplest way, is just to fly something by a gravitational body and do the math. And the math just tells you the faster you go, The higher your velocity as you go by, the less you're going to be pushed in this direction. So the less sideways motion you're going to gain, velocity sideways. So it's like dropping something in gravity, okay? The fact is, okay, the fall, you can't change the falling time. No matter how fast I throw it, it will land in the same time that something just falling lands. That the gravity, okay, isn't consistent over distance. It is consistent over time. And clearly in this example, it's just telling you the truth. It's telling you the faster you get through whatever this force is, this force of gravity, this stuff, this bent geodesic, it affects you, okay, only while you're in it. And when you're not in it, it doesn't affect you. And it affects you just in little units of time. So if you're only in it for 1 second, you only get 1 second of pushing. If you're in it for 10 seconds, you get 10 seconds of pushing, and you'll be pushed right into something. So obviously slow things crash because they have a lot of force pushing them. Fast things don't crash because there's very little force affecting them. I mean, this is a fact, okay? Well established, in my opinion, fact that it's a time-dependent force. And this is where all of this starts. So this whole nonsense about kinetic energy all began with Leibniz and this notion, okay, that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. So I could draw that a little better. I'll just draw the arrow. And that they weigh the same, that it's the same energy there. Those two objects have the same energy. When no, the truth is, if you actually did measure it with a scale, all right, they don't have the same energy. This is a 1 and this is a 1/2. Whatever value this has, this is going to be half that value because of the fact that it's a 1 here instead of a 2. This needs to be a 2 for this to be the same mass. And the reason why this, you can contrive it, right? So Lyndon LaRouche, the fans of Lyndon LaRouche, okay, conspiracy nut crazy person who should run for president, those nutters, okay, they believe your Leibnizian theory with a passion for some reason, and contrive explanations to make this real, in the sense that they say, well, if we use pulleys, then we can make this true in terms of distance, okay, because then we can make the distance the same. The amount of rope you have to pull will be 4 times the distance, and so therefore you'll make these things equal. But that's it's a contrivance. It's a nonsense. So yes, let's say if I want to lift these two things and I decide to lift this one at a much slower velocity than this one than this one, I can make it more work, all right, but I can't do it by dropping it. By dropping it, I'm going to fail. But yes, if I decide to lift this one, okay, twice as fast as I lift this one, well, then I can fix this 1 and turn this 1 into a 2, and I can make it equal. So if I do this, if I change the speed at which they will hit the ground or hit the target, then I can do more work. So I could lift 100 pounds, in 10 seconds. Or I could lift 100 pounds in 1 second. If I lift it in 100 pounds in 1 second, I'm going to do 10 times less work. Because I'm not going to be holding the 100 pounds. I'm not going to keep pushing it for those full 10 seconds. So you can make lifting something into more work. But you can also, by doing it quickly, make it less work. Because it's a time-dependent force. All that matters. So let's understand their work equation. I mean, the professors of physics, that is professors, doctorates, people that did a doctorate in physics, will actually say to you, I can give them a 10-pound weight and say, hold it up. And if they can keep it steady, they'll say, physics says you're not doing any work. Now, you know, and I know, you're doing work to keep it in its position in gravity. That you're basically taking the ground's place and you're providing the counter force to keep it in one place. it would fall if you didn't provide the counter force. It's just a fact. A fact. It would fall if you didn't provide the counter force. And it only weighs 10 pounds all the time, right? It doesn't weigh 10 pounds. It doesn't weigh 500 pounds when you're at this location, and weighs, 5 pounds down here. No, it weighs 10 pounds. Here, 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 here. No matter where it is, it's always 10 pounds, and it's always the same amount of weight that I'm pushing. And it's just about how long I take to push it. So the quicker you can get a mass raised, the less work you'll do. Now, obviously, if I raise it really fast at 50 miles an hour, I'm going to have to slow it down to stop it, because it's not going to stop. 50 miles an hour takes time to drag to a halt, so I'm going to have to work to slow it down. So I can overshoot a position, okay? But the fact is, I can launch it with a velocity that'll get it exactly to this point. And I can launch this with a velocity that gets exactly to this point. And that launching velocity for these two objects is going to be just as the same here. It's going to be 1/2 the difference. This will be twice the velocity that this will require, not 4 times the velocity. Anyway, so what else needs to be said? Yeah, so gravity is a time-dependent force. The fact that Leibniz didn't understand that, the fact that it was even under dispute seems kind of strange, since it's really something Galileo documented fairly completely. It's almost like nobody else needed to comment on it. Now, Huygens did, and so he's partly, I guess, to blame for this misunderstanding. But he never said it wasn't a time-dependent force. He never said distance is what causes gravity. That is, how far you fall in the gravity causes you to have gravity. He understood, I think, quite well that the distance is just correlated to the velocity. That the time is the real source of the energy. And the distance, just by a matter of fact, is you're collecting the velocity in mathematically precise amounts, and it is tested with Galileo's 3, 5, 7, and then the square roots of those 2, 4, 9, and that's all that this is. There's a correlation between distance falling, but there's no correlation where distance is causing the gravity. It's the time that's causing it. The fact that the time means you will have a certain velocity, because the gravity is always the same for every unit of time. It produces a new amount of acceleration, and you get to keep the previous acceleration. It's the keeping the previous acceleration that causes this effect. Keeping the previous acceleration is what's causing that effect. But the correlation is not elemental. It's just circumstantial. And this is the real cause, and this is just an effect. And so if you think the effect is the cause, you're going to get the answer wrong, because time isn't squared. Alright, so let's see what else. How else can I say it? I'll think about it for a minute, and then I'll just say, that's just what the argument's about. It's, in my opinion, it really shouldn't be an argument with intelligent people. Intelligent people should be able to concede. I just wish that the people who say, I am wrong, I wish they would admit and say overtly that they believe that the force of gravity is created by how much distance you travel in gravity. That all that matters is how much distance I travel. It doesn't matter how fast I travel that distance. I just wish they would say that nonsense and demonstrate themselves to be, frankly, as dumb as a flat earther. I guess I will add the argument that what I have demonstrated, I just had a minute ago, my scale. But anyway, that you could put a scale sideways and you could simulate the force of gravity, the thing that causes weight. We kind of, again, physics kind of says, okay, weight only happens in gravity. Somehow the only way you can ever have a weight is that the weight has to be created by gravity pushing on something and that no other force could duplicate weight. Some kind of notion like that. When the truth is, no, you can just, take your scale, your traditional scale, and just tilt it sideways. And now all you have to do is create a velocity. Just take a mass, give it a velocity, and you can measure its weight. That's what you'll be creating. The fact is that the gravity creates a weight commensurate to something moving 1 mile an hour. So if I might move this 1 mile per hour, any object, I can make it weigh on the spring its mass. So if it weighs 100 kilograms, I can make it show that on a scale, put sideways, by just giving it a velocity of 1 mile an hour. Now if I want it to weigh 200 pounds, I just make it 2 miles per hour. If I want to make it 3 kilograms, I just 300, I make it 3 miles per hour. It's that simple. There's nothing tricky about it. I want to double something's weight, I just double the velocity with which it's moving. And the fact is although you don't see yourself moving in gravity, as pointed out, it's a fact, okay? It's a fact that you have to understand you are moving. You have to be continually moving into the earth for the earth to be continually pushing you back. You do understand you couldn't feel the pressure if there wasn't pressure pushing down. There can't be any push back unless there's a push down first. So yes, the first act is the push down, and simply put, the earth pushes back, and then you push down and the earth pushes back. And if you add up that motion, what it adds up to is 1 mile per hour that you're actually moving, okay, in the direction of the scale, and the scale has to push you back. Now the scale doesn't push you back, that's what the spring is for, is to show you what the differential is. The differential between the push back and the push in. The spring is basically just showing you that differential because it's ignoring one of the pushbacks. And so it's basically showing you what the amount is that you're moving into the earth. And yeah, so it's that logical and simple. I mean, twice the velocity, twice the weight. 3 times the velocity, 3 times the weight. A simple, logical proportionality now. And Isaac Newton said this overtly. You want to go twice as fast, you apply twice the force. 2 F's equals 2 velocities. Okay? 3 F's equals 3 velocities. And of course the inverse is true. Alright, you want to apply twice the force, you double your velocity. You want to triple the force you apply, you triple your velocity. This is Isaac Newton's physics, okay? Isaac Newton's physics isn't distance, okay? It is work. Time is work. How much time going what velocity is how much force you can apply. You just add it up. Per hour or per second. You just add it up per a unit of time. So even that, they should have at least, just to show a little bit of integrity, they should be willing to state that, their perversion math of, F equals ma, and I'm going to turn that into F equals mass times velocity squared. Because I'm going to pretend this acceleration is some kind of per second squareable function. But it's not Newton's math. It's not Newton's belief. It's not Newton's philosophy. And that the Newtonians fought against it. They wrote letters to the king and to the queens. Mostly wrote letters to queens, I guess, and tried to hope that the queens would, and the sister of the queen would, the king, would persuade the king, to shoot the other guys because they're doing bad physics. But that's what the appeal was. And they appealed against Leibnizian physics. Leibniz tried to get, to to try to point out that the Newtonians are evil atheists because they don't believe in this magical kinetic energy stuff, this mv squared. And the Newtonians had to fight back and make the argument that no, there's nothing wrong with our physics, and there's all kinds of wrong with his physics. And the wrong side won the argument, frankly, over the long term. I mean, over the short term, while Newton was still alive, the right guys, the right theory wins. And then later on in France, everything goes sideways, and everybody's fooled by dropping round things, denting clay with round objects. They're fooled by pointing an arrow. I do my experiment by pointing an arrow going, say 10V, and then I take another arrow and I put a square on it. Okay, and I can fool morons, right? I could fool a moron, right? I could have these both go 10 miles an hour, and I could say, see, look, this one, didn't penetrate as far, therefore it must have less energy. So that's the experiment they did. They basically said, let's have a competition between different shaped objects, and that'll somehow prove how much energy they have. And to science's, you gotta argue, disgrace, they fell for this. Okay, yeah, they got snookered, completely snookered with a bullshit experiment. And that's the state of your physics. Now, I think everything I've said here is factual. I don't think I've cheated any truth anywhere. And but no one will argue these arguments. Instead, they'll say, we've proven it. They say they've proven, okay, something contrary. And they've only proven it the same way the pointy arrow people prove something, by fooling morons. So, enough said. So, till the next time and such, and so forth and whatnot. But it really is a dismal circumstance that there are so few people that can figure out the obvious mistakes. The obvious lie, okay, that Newton didn't believe this crap. He said exactly the opposite, in the sense that he made it overtly clear he thinks this is a force equals velocity. That you want to change something's momentum, you double the force, the velocity. Simple enough. Big lie they have to use that somehow this is Newtonian physics, and then just ignore all the rest of the evidence. And again, ignore the fact that if I do these experiments in space, moving a spaceship, and I do the 2,000 joules of the bullet out one side, and I do the 2 joules of energy going out the other side in the recoil of the gun, they will admit that the spaceship keeps going straight, that the spaceship can't see the 2,000 joules. It only sees 2. It sees the same as whatever the gun has. It sees the same going out the other side. The same momentum. Because momentum is what moves things in the universe. It's just about mass and movement. That's all there is in the universe. That's all that makes it go. Big masses, okay, have to move a little because they have so many mass components. Little masses have to move a lot to equal each other. 1,000 atoms moving 1 mile an hour, same force, same energy as one atom moving 1,000 miles an hour. Newton believed it. I think Galileo believed it. I think Descartes believed it. And it's kind of shameful that somebody has to show up in 2023 and defend those beliefs.